All right, hello students. In this video, I'm going to try to explain Unit 4. And if I speak too fast, try rewinding me. So that way the video doesn't take too long. I'm giving you two different scenarios. One where the football is being passed, and here where the football is being punted, okay? And these are the functions that model the flight of the football. You can see one of them is in standard form, and the other one is in vertex form. Right. So these are good things to notice, but at the same time, we have Desmos, so also being able to use Desmos is critical. We have to answer these questions for both scenarios. So let's start with the first scenario, negative 16x squared. So I go to Desmos. Squared plus 30x plus 6. All right, let me rearrange my screen so that I can see it better. Here we go. What is this thing? Why is it in the way? I don't know. First question, what is the height after 0.3 seconds? For this, all you have to do is f, open parentheses, 0.3, and Desmos evaluates the function for you. So it's 13.56. So I'm gonna use one color for top one, right? So what is the height after 0.3 seconds? It's 13.56. What is the maximum height? For the maximum height, you need to read the vertex. Remember, it's the y value, 20.063. How long did it take to reach the maximum height? That's the x value of the vertex, so 0.938. When did the ball hit the ground? For this question, you're looking at your zeros. So 2.057. When was the ball at a height of 15? Once again, this one is the height of 15. Remember, this one was 0.3 seconds. So this is input, okay, time. This is output, height. So to solve this, we do it differently, okay? We go to Desmos, and we don't plug in 15. We want the output to be 15. So we want this, we want the function to be 15. Right? That gives us both solutions at 15. That happens at 0.375 and at seconds and at 1.5 seconds. Okay. I was a little remiss about the units here. What is the height? So this would be in feet. What is the max height? So this would also be feet. How long did it take? So this is seconds. When did it hit the ground? Seconds. Okay. And the last question, what was the starting height? The starting height is your y-intercept. Okay. So I have to go back to Desmos and get rid of the 15. Type the f of x again. And now I'm looking for the y-intercept. So the y-intercept happened at a height of 6 feet. Okay. All right, so now we're going to do the same thing with this function. I'll just use a different color so that we can tell the answers apart, okay? So the first thing is we come in, we type it. This one is g of x, negative 16, but then things change. Open parentheses, x minus 1.25 squared, and okay, plus 26. Sorry about that. Here we go. Plus 26. All right, so now we have the parabola. First question, what is the height after 0.3 seconds? Remember, that's input. So we do G of 0.3. And this tells us that it's at 11.56. All right, so for the second one, it's 11.56 feet. What is the maximum height? When you want the maximum height, you go to the vertex and you're looking for the Y value. In this case, the Y value is 26. How long does it take to reach the maximum height? That's your X value. So it takes 1.25 seconds. When does the ball hit the ground? That's your 0. So it takes putting this in the wrong place. It takes 2.525 seconds. When was the ball at a height of 15? Once again, this is not the case where the input is 15. Right? We want the output to be 15. So I'm going to come over here. I'm going to change this to 15. All right? On the x-axis, I can read their value. So there's 0.421 and 2.079. What was the starting height? Okay, I get rid of the 15. I type f of x, and I look for my y-intercept, 0, 1. So my starting height was 1 feet. Here, and I'm gonna try to redeem myself. These are the answers for the first question. These are the answers for second, third. Even I'm having trouble figuring out who goes with who. These are the answers for this question. And then these are the answers for this last question. All right. That was number 2. Function transformation. Describe how the football paths are affected by the changes. Okay. So it doesn't matter which one you use, right? So you can use, this is the -9, so we go to -5, and then +5. Even more space, we'll leave it like that. All right, I hope this works. So I want to do 3 times f of x. So looking at these functions, as you can see, originally it was this. It kind of got stretched. So okay, remember our transformation cheat sheet right here. We're looking at a case where the function is being multiplied by a number. In this case, this number is 3. Okay? So when the number is greater than 1, it's going to be a vertical stretch. Okay? Right? So what happened to the path of the football? Let's see. Originally, it was the blue path, but because of the vertical stretch, it's now the black path. So it looks like it goes higher, it goes 3 times higher, but same amount of time, right? Because it starts at time 0 and it still comes down at 2.525 seconds. Wow, so it must go faster. 3 times higher, but takes the same amount of time in the air. All right, with this one though, we're plugging the 3 inside the vertex, right? So if we take a look at this, it's this situation right here, where we're multiplying the input by 3. So when it's greater than 1, it's a horizontal compression. Ooh. Now let's look at Desmos. So instead of multiplying by 3 on the outside, we multiply by 3 on the inside. Now let's zoom in so we can see what the heck is going on. All right, so it looks like they both start at the same place, right? The blue and the black one, but the normal path is this one, and it gets compressed, right? It's shrunk. See, it's thinner. It goes through the same height, but it goes up and it comes back down, so it stays less time in the air. So it's a thinner path, right? I don't even know how to describe it. Less time in the air. Same height. Same max height. It's been compressed. It looks like an accordion that's being compressed. All right, this time we're going to multiply by 1/2. Okay, so through. I don't think the multiplication sign is necessary right here. See? Okay, so the blue is the original path. But when we multiply by 1/2, go back to this, right? We're multiplying by a number on the outside. And this number is between 0 and 1, so it's a vertical compression. So it makes sense, right? It doesn't go as high as before. So it's being vertically pushed down. So same time in the air, but it doesn't go as high. Now we're going to multiply by 1/2 on the inside, the input. So, right here. Right. The original path is the blue one. Let me look over here. So we're multiplying on the inside, right? Oh, sorry, it's already over here. Right here, RC is on the inside of the input, but it's a number between 0 and 1, so it's a horizontal stretch. So, yeah, see, originally it's the blue path, right? But it's the normal path, but the new path is going to be this. Oop, I drew it wrong. It goes up, it goes to the same height. It goes to the same height, but it's actually, it takes longer in the air, see? It lands sooner. Originally, it takes longer to land because it travels more in the air, but the same height. So it's just being stretched horizontally. All right, f of x plus 2 plus 2. Everything just happens 2 units higher, right? All right. Key characteristics of both footballs. So you might have noticed that these answers are going to be the same thing as number 1. Yeah? It's talking about these two scenarios, and it's these questions right here. So I'm going to go ahead and put the answers in here, and I hope you realize that they're the same answer, which is why I'm not going to explain how to get them. Rewatch number 1 if you want an explanation. Okay, there, I paused the video and I went ahead and I wrote down all the numbers. Domain and range. All right, since I already have the second one typed in, we're going to work with, right here, scenario B. And the question is, what is a domain? So the domain is the valid x values. And in this case, since we're talking about throwing a football in the air, it can only, and this is the ground, right? We said the x-axis is the ground. When the football hits the ground, it's going to stop. It's not going to go and keep going underground. All right, so we can only assume that the path of this football can only exist in quadrant 1. All right, so the initial, wait, I think that's another 0, not the, all right, so we start here at time 0, initial height of 1, and it ends here when it hits the ground. So from which x to which x? From time equals 0 to time equals 2.525. Okay, so time to hit the ground. See? From 0, because time starts at 0, and until the time where it hits the ground. All right, the range, the range is the lowest height to the maximum height. Well, then think about it, okay? What's the lowest height? The lowest height is the ground, which is 0, correct? So we cannot go lower than 0 for height. What's the maximum height? Well, the maximum height is 26. The football doesn't go higher than 26. So our range goes from a height of 0 to a height of 26. And so this has to do with the max height. Let's try this again with the other function. And of course, I don't remember what it is, so I am going to have to travel back. Here we go. F of x equals negative 16x squared plus 30x plus 6. Okie dokie. All right, and same deal, right? The football is only going to travel from its initial height up in the air, and then it's going to hit the ground, and then it's going to stop. So from which x to which x does this function exist? Well, from time 0 until it hits the ground, and it hits the ground at 2.057. Right, so once again, now for the range, the lowest height of the football is 0, and the highest height of the football is 20.063, the maximum. So that's your range. All right, identify which expressions are equivalent to x squared minus 81. Yes, we can do algebra and we can simplify it, but it's going to be easier if we just compare them by graphing them. So it's x squared minus 81. All right, so it's this graph. Clear? All right, the first one says x squared minus 9x plus 9x minus 81. All right, if I click on the blue one, I click on the green one. So you can see that there's perfect overlap, which means they're the same expression. And they're the same expression because this cancels with this and you're left with x squared minus 81. All right, now let's try the other one, which is x minus 9 and x minus 9. Clearly, we can see the blue is the original one and the green does not overlap, so they are not equivalent. All right, this one says x minus 9, but this one is x plus 9. So this changes this to a plus sign. And as you can see, blue original, green perfect overlap. So these are equivalent. All right, let's look at E. And E, ooh, more typing. Here we go. Get rid of this. Always leave the original one up so you can compare. Parentheses 2x squared plus 20 minus x squared plus 101. Let's see, original one, new one, perfect overlap, equivalent. All right, the next one. Two x squared. I have a feeling I shouldn't have erased that, so here we go. 2x squared plus 20 minus x squared. This changes, this plus sign becomes a minus 101. Okay, so they're not the same thing. Blue is the original one, purple is the new one, and it's not an overlap, so they are not equivalent. And I think I skipped A, didn't I? My bad. Okay. So we type it in 81 minus x squared. Oops. No, come down. There we go. Oh, there's no overlap. Original one, purple one. It's actually inverted, which makes sense because the negative sign is in front of the x squared. And so this one would be no. Right. Find the solutions to. The solutions are your zeros, your roots, your x-intercepts. And so the easiest way to do this is to use decimals. And all you have to do is type them in. Right, so you do 3x squared equals 10. And you get this one and this one. Right? Then the next one is 3x squared equals 10x. So I'll come over here and I add an x. And that gives me these two roots. This last one is negative 8x squared plus 5 equals negative x. Oh Lord, what is this? Well, there you go, there's two roots. Oh, let me write these down. This one was negative 1.826 and 1.826 in positive. This one was 0 and 3.33. This one was negative 0.731 and 0.856. And this last one, what's different? Negative 8x squared. There's an x under 5. And it equals 10, not negative x. Okay. Zooming out. What is going on? There are no solutions. Clear? So since there's no solutions, there are no roots. Create a table for each function. So with this one, students were asking me, hey, how do you know which x values to use? Well, I use the x values that help me draw the part of the parabola that has the vertex. Okay. So in this case, this is the vertex, right? So I want to, this is the origin right here. So I want to draw this part right here so that we can see the parabola. So I would start at x equals -5, right? That'll capture all of this, and I would probably end it at 5. So that's a lot of numbers. Maybe we'll start at -4, clear? All right, so I would do this at -4, -3, 1, 2, 3, and then 4. Clear? Okay, so the next one, -4. All right, that's -28. I feel like I should make this shorter. Here we go. Okay. Oops, -3 is -7. -2 is 8. -1 is 17. 0 is 20. 1 is 17. And see, it makes sense because this is the highest value. What would we consider the maximum? I'm going to type in 2. So that's 8. Type in 3. You can see the symmetry, right? How the values are repeating, right? Because first we were going up, now we're coming down. And the axis of symmetry is right here, the y-axis. -7. And the last one will be -28. So we can, from here, you can see the maximum, right? I would say that that's the maximum, the vertex. Let's try again with the other one. So with this one, the only difference is I took the negative sign away. Okay. All right, once again, the axis of symmetry is right here. The origin, which axis am I going to use? So that's -10, this is -2. I guess we can start with -3, so that we're doing less work. All right, so +3 is over 20, so let's get our numbers. F of 3 is 47. F of 2 is 32. F of 1, 23. See, it's still going down, so we haven't hit the minimum. 0 is 20. 23. 32. Okay, so see, now it's starting to repeat itself. So it looks like 2023, it looks like this is the minimum. So after that, you see 23, 23, 32, 32, 47, 47. Yay. Find the rate of change between these values. So remember, these are x values, okay? So this is x1 and this one is x2. So we're looking at x equals 0 and x equals 3. Corresponding y is 3. The corresponding y here is about 6. Clear? All right, so the two order pairs are 0, 3, and then 3, 6. Remember, we do the y value, subtract the y value, so 6 minus 3 over 3 minus 0, 1. So for this one, when x is 3, right here, 6, and when x is 6, right? So calculating this, I forgot to write the next one, right? 6 goes with 3. All right, so 3 minus 6, right? Bottom y, subtract this top y, over bottom x, subtract this top x, so 6 minus 3. And I get a negative 1, which makes sense because the slope is going down. What is the domain of the problem in number 8? Well, from which x to which x does this go? Let me erase this. It goes from x equals 0 all the way to 7. Those are the x values. Uh-oh. All right, so what is the domain of the range? All right, so I was in the middle of it. So the domain goes from 0 to 7. Oops, I need a pen for this. Okay, and the range, the lowest y value is this one, and the highest y value is not 3, is 6, right? Well, close enough. So I need to write that one down. What happened to my pens? That's because I shrunk my screen. From 0 to 6. So yes, the range is the lowest y and the highest y, and the domain is your x's. Clear? I hope it's clear. All right. When the quadratic equation is in each of these forms, what key characteristics does it help us find? Oh, this is in standard form. So the main thing that we can find is right here, the initial value. Of course, other things, but I mean, you can automatically just look at it and know the initial value. This one is in intercept form. And what we can really get from here automatically is the roots. What are they called? Zeros, also known as zeros, solutions, x-intercepts. All right, this one, ax minus h squared plus k, this one is in vertex form. And of course, the key characteristic that we can get is the vertex. So if you want the roots, you would change it into intercept form. If you want the vertex, then you would change it into vertex form, okay? Ooh, compare the functions. All right, so there's two different functions. There's f of x, which is this one. And there's g of x, which is this one. All right, one at a time. Let's do the first one. F of x equals plus 3, x minus 5. Right. Does it have a maximum or a minimum? It has a minimum. I need to shrink that. What is the value of this extrema, or what is the value of this minimum? I use that word so I wouldn't have to, negative 16. What is the axis of symmetry? The axis of symmetry is the x value of the vertex. So x equals 1. And write that down. X value of the vertex is the axis of symmetry. Does it open up or down? It opens up. And what are the x-intercepts? Well, right here, negative 3 and 5. All right. Whew. G of x. Now, for this one, you will need to learn. Clear? So you can do it two different ways. You can type in the ordered pair. So negative 2, negative 15. Okay. Negative 1, negative 16. 0, negative 15. 1, negative 12. There's more. 2, negative 7. All right, so we actually only get the partial of the parabola, see? But this is enough to let us see that this point down here, this one is the vertex, the negative 1, negative 16. All right, so does this parabola have a max or a minimum? Well, it looks like it has a minimum, okay? What is the value of this extrema, of this minimum? Voila, see, they both have the same minimum, negative 16. Axis of symmetry, this one has a x equals negative 1. The axis of symmetry is negative 1. Does it open up? Yes, it does. What are the x-intercepts? I can't see them. So I can't see them. All right, I hope you enjoyed the review. Please get a 100 on the test tomorrow.